Hi, welcome to Red Bull Racing, Red Bull Technology. My name is Steve Nevy. I'm the Business Development Manager here. It's going to be my pleasure to show you around our factory. This is where we make our carbon fibre parts. Carbon fibre is an amazing material, very, very strong, but very, very lightweight as well, which is important to us. You'll find carbon fibre in the aerospace industry. Helicopters and particularly fighter aircraft are made in carbon fibre. The process is interesting as well. The carbon comes to us as a woven sticky cloth in different grades. Our guys will take the cloth, will cut it to shape, and then we'll lay it into moulds, layer upon layer upon layer. Maybe 30 layers, maybe 50 layers. The whole thing then goes into one of our autoclaves, which is basically a pressure oven, where it's cured at a temperature of about 140 degrees C and 7 atmospheric pressures. The effect of that curing cycle is to turn that sticky cloth into that very, very strong and stiff material that we make the racing car from. Once the carbon components have been in the autoclave and the carbon's been cured, they come into here where they're trimmed and parts are bonded together. In fact, you'd be surprised how much of a racing car is actually glued together. This is a fascinating process called stereolithography. These machines are, on one side, a deep vat of liquid epoxy resin. On the other side is a computer. Our designers produce three-dimensional designs, which are then downloaded into this computer. This computer then projects a laser from one side of the machine onto the roof of the machine and down onto the surface of the resin. Where the laser touches the resin, it solidifies it, layer by layer by layer, until eventually we've produced a three-dimensional object inside the liquid. The whole thing rises up out of the resin and gets cured and onto the wind tunnel model. We produce a scale model of the car, which we test for aerodynamics in our wind tunnel. The Concorde aircraft was tested in that tunnel many years ago. But it's our tunnel now, where we test. It's a constant battle between downforce and drag. It's important that we make the car as aerodynamically slippery as we can so that it cuts through the air nice and cleanly with a minimum of drag. But we want the downforce because at some circuits it's important to get us around corners very, very quickly. Different circuits require different types of aerodynamic configurations. The two extremes are in fact Monaco, where there are lots of tight corners where we need downforce to push the car onto the track to increase grip. The other extreme is in fact the Monza circuit, which is lots of straights and big, long, sweeping corners, where we would reduce the amount of downforce to get the car to go faster in a straight line. We produce many components for the wind tunnel model, far more than we do for the car itself, because this is the experimental stage. This is where we're trying lots of different ideas. Those that work make it to full size and actually appear on the race car itself. Now, although much of the car is made in carbon fibre, we still make many components in metal. Lightweight metals like aluminium or titanium or magnesium for areas of the car like gearbox, hydraulics and suspension. One of the reasons we use these lightweight metals is because our objective is always to try to reduce the weight of the car as much as possible for competitive reasons. And for that same reason, we will machine these components into very fine detail. We use the big 5-axis milling machines in the manufacturing process for some of the larger items like the chassis. We also use them for producing the tool and block patterns, which are the basis for the carbon fibre moulds in which we'll make the composite parts themselves. The car is in this initially painted here in our paint shop and in fact comes back every time the car runs at a test or a Grand Prix. A stone chip does a lot of damage at 200 miles an hour, and it's really important that the car looks at its very best because of course it's representing our Red Bull brand along with the brands of our partners. In our R&D rig test room, we're able to test individual systems from the car, for example, our braking system. But what we're also able to do on our 7-post hydraulic rig is to test the entire dynamics of the car. We're able to put a full-size car onto the rig with 7 hydraulic actuators. There's 1 under each wheel, 2 under the engine and 1 under the nose. Now, one of the things we're able to do is to put the car through a whole range of frequencies to see where different parts of the car vibrate. Just like in a road car, when you get to a certain speed and your dashboard starts to vibrate, different parts of our race car will do the same thing. But it's extremely violent, so we need to know where those points are. Also, and more interestingly, we've recorded telemetry, which means that we can simulate any of the circuits that we race on. Now, although we use computer simulation more and more these days for engineering analysis, there's still a requirement to make physical tests. We may put a nose onto this rig and make a fatigue test, push it up and down and side to side. Another test that we have to apply by regulation is to apply hydraulic loads to the chassis. We squeeze it and we put loads onto it. In fact, the load that we put onto the roll hoop, which is the piece behind the driver's head, is equivalent to putting a double-decker bus full of people onto the top of the car. Well, this is the last stage in the factory. This is where all of those aluminium and titanium and carbon fiber parts come together for hydraulic and electronics and aerodynamics. And of course, the 3 main components being the chassis, the engine and the gearbox. This is where they come together. The car is then transported to the Grand Prix to compete, and afterwards, this is where it comes back, to be dismantled, for parts to be sent in different directions, to be quality inspected for hairline cracks and other flaws, and in some cases replaced by better parts to make the car go even faster. So that's Red Bull technology and Red Bull racing. That's how we design and test and build our racing cars. I've thoroughly enjoyed showing you around. Thanks for visiting.